come back to Dawn if we have chance, but I want to turn now to Chris Clarkson, then Erin Bell.
Thank you very much, Chair. Thank you for appearing today, gentlemen. I just want to go back to the testing, in particular to PCR testing. I want to understand at what rate have you accounted for false positives and false negatives in your modelling, and what are those rates?
Yes, I'm not sure I can give you an exact answer on that. I mean, PCR really doesn't have much in the way of false negatives apart from swab negatives. I mean, it's very sensitive, picks up lots of things, even can pick up very small amounts of RNA, which is one of the reasons that it probably picks up people who aren't actually infectious. It picks up people who've got some residual RNA from having a virus. So in that sense, it's a false positive in terms of the infectiousness. But I mean, PCR is extremely sensitive and doesn't, as I say, apart from swab failures, doesn't really have a big false negative in that way. And I'm not sure it'd make a big difference to any of the modelling assumptions.
So if I can just add one additional thing to that, which is, in terms of the ONS data, which is the gold standard, they have a really good technical series of slides on that, how they've made their estimation on PCR, which I think is probably the best way to look at that. It's quite a technical area. The point I'd make as an epidemiologist, though, is the key metric is actually not the sensitivity and specificity, although that's important. It's a positive and negative predictive value, which varies by point prevalence at a point in time. And in fact, the testings on those will become more accurate, depressingly, as the prevalence rates go up. So that the risk of a false positive is higher when the rates are actually lower.
And the risk of false negatives?
The converse is true, but we're at sufficiently low levels, it makes much less difference about that.
So if you had to put a figure on it?
On false negatives?
Yeah.
Well, it depends what use you're using it for, basically. Is it a clinical use or is it an epidemiological sampling use? So the epidemiological sampling use, I would refer you to the ONS data because I think there's a really good technical document on that. For clinical use, what you're really wanting to do is pick up those people who've got symptoms that are important enough to actually want to do something about it. And I think the big risk there is actually about sample acquisition more than it is about the actual lab side of it. The lab side of it's pretty good. But do you do swabs properly? And that's one of the reasons that I'm very keen, for example, that we're moving, particularly for things like social care and NHS staff testing over towards saliva testing, because that has a much lower difference, if we can get it right, in terms of sample acquisition.
Thank you. Would you be able to make that ONS document available to us?
It's public.
It's public. It's a public document, but I can point you in the direction of it.